All right, hi folks. This is Larry Mussolino. I wanted to record a video for one topic that is a little challenging, and it's this topic right here: solving a value mixture problem using a linear equation. Now, this is actually going to be similar to the previous topic right here that says writing a multi-step equation. Now, I recorded a separate video for that topic. So maybe before watching this video, you want to go check out that other video as a little bit of background information. All right, so let's get started. So I'm going to pop up an example from Alex here, and let's get started. All right, here it is. So it says at the movie theater, a child admission is $6.10. Adult admission is $9.90. On Sunday, 3 times as many adult tickets as child tickets were sold, and the total sales were $1,074. How many child tickets were sold that day? All right, well, the first part of this kind of a problem is understanding the basic relationship between the quantities that are being mentioned. Here's what I mean. I'm noticing there's an admission price. You could think of this as a per ticket price, right? For example, a child has to pay $6.10 to get in. Then there's also the number of tickets sold. If I take the admission price per ticket and multiply it by the number of tickets sold, that gets me the total sales. Let me give you a quick example. So let's say it's $6.10 per child. But let's say I end up selling 100 child tickets. Well, I would multiply those two numbers together. That would be $610 in sales that I would take in. All right, well, I'm going to set up a table because I think setting up a table here is going to make things a little easier. So let me set up a table. This is going to be the type of ticket. Then there's going to be the price per ticket. Then there's going to be the number of tickets sold. And then the last column is going to be the total sales. And from the example I just did a second ago, I know the relationship here. If you take the price per ticket and multiply it by the number of tickets sold, that gets you the total sales. All right, let me start filling in this table. There's a child ticket versus adult ticket. And I know the price per ticket that was given to me in the problem. For the child, it was $6.10. For the adult, it was $9.90. All right, let me come over to number of tickets sold. Now, nowhere in this problem do they mention the number of tickets sold. Well, let me start out letting X equal the unknown quantity. Usually that's a good starting point for any kind of algebra problem like this. Let X be the unknown quantity. Well, I could see the unknown quantity is how many child tickets were sold. So I'm going to let X be the number of child tickets. So that means I'm going to put an X right here in this box. I need to fill in somehow this blue box. This blue box is the number of adult tickets sold. Let me come to this sentence. It says 3 times as many adult tickets as child tickets were sold. But I know the child tickets we're calling X. 3 times that would be 3X. So the way I'm going to write adult tickets is 3 times X. So 3X. Now I'm going to multiply straight across in these rows to get the total sales. So I'm going to take 610 times X, multiply those. That's going to be 6.10x. Let me go to the second row. It's going to be 9.9 times 3x. Let me write an equation. If I take the child sales plus the adult sales, that has to equal the total sales taken in. But I know the total sales taken in that was given to me in the problem is $1,074. All right, let me fill in the child sales. Well, according to my table, that's 6.10x. Let me do the adult sales. That was 9.9 times 3x. All right, let me keep going. I'm going to multiply 9.90 times 3 here. And by the way, notice the Alex calculator is available for this problem. So you can open up the calculator and use that. 9.90 times 3 turns out to be 29.7. All right, well, these are like terms here on the left-hand side. So I can just add these together. 6.10 plus 29.7. What is that? I'm going to do that in my head. I think that's 35.8x. Let me just double check that. I think that's right. Last step, I want to get x by itself. I'm going to divide both sides by 35.8 to get x by itself. And I'm going to work this fraction out on my calculator. So I'm going to work out 1074 divided by, let me show you the Alex calculator. That's better. Let's do it on the Alex calculator. So I'm going to come over here and click on the Alex calculator. And I'm going to enter in 1074 divided by, notice it shows a little fraction, 35.8. And I hit the equals button, and I'm getting 30. So it looks like x equal 30. So there were 30 child tickets sold. So that's the answer, 30 child tickets. All right, so I think setting up this table is a good idea. Let me do one more example. Let me go grab another example on this. Let's see here. This one's similar. Let me grab one. Let's do this one. All right. It says here there's a coffee shop that makes a blend of two types of coffee. There's type A coffee that costs Ahmad $4.35 a pound. Type B coffee costs $5.75 a pound. This month they used twice as many type B as type A. The total cost was $459. How many pounds of type A coffee were used? All right, let me start off thinking about the relationship here. Well, if you take the cost per pound of coffee and multiply it by the number of pounds you buy, that's going to equal the total cost for that coffee. Let me give you an example. Let's say the cost per pound for coffee is $5, just to make up an example. And I go into the store and I buy 6 pounds of that coffee. Well, that would cost me $30 altogether, right? Because I'm buying 6 pounds, but each pound is $5. It would cost me $30 altogether. All right, I'm going to set up a table again. Here's my table. I'm going to put the type of coffee in this first column. I'm going to put the cost per pound in this next column. Then I'm going to put the number of pounds in this column. And finally, it'll be the total cost. So let me start filling in. I know there's two types of coffee. We call them type A and type B. I know the cost per pound that was given to me in the problem. Oh, by the way, I remember that if you take the cost per pound and multiply it by the number of pounds, that equals the total cost. So I know that basic relationship. All right, let me start filling in the cost per pound. I know type A coffee is $4.35 a pound. Type B coffee is $5.75 a pound. That's given to me in the problem. All right, what about the number of pounds for type A coffee? Well, of course, that's the unknown quantity. So I'm going to label that as X. So I'm going to let X equal the number of pounds of type A coffee. So I'm going to put an X right here. Let X. How about the number of pounds of type B coffee? Well, again, we don't know that, but here's what it said. There was twice as many pounds of type B coffee is type A. Well, that means I'm going to put 2x here because twice means multiply by 2. All right, now let me go ahead and fill in the number of pounds. I'm just going to multiply straight across. So 4.35 times x for the first row. For the second row, 5.75 times 2x. All right, if I take the cost for type A coffee and add the cost for type B coffee, that has to equal the total cost for all the coffee. But I know the total cost for all the coffee that was given to me here is $459.60. All right, the cost for type A coffee was $4, 4.35x. The cost for type B was 5.75x. Well, this is an equation I can solve. Let me take this 5.75 and multiply it by 2. Again, you have the Alex calculator enabled here, so you feel free to use the Alex calculator here. I think that's 11.5x. All right. And let me go ahead and add these like terms together, right? Because I have 4.35x and 11.5x. I can add those together. What does that work out to be? 15.85x, I think. Let me write it up here to finish it. Whoops. So here's what we have. 15.85x equals 459.65. Last step, of course, I want to get x by itself. I'm going to divide both sides by 15.85. I have x by itself. This fraction here, of course, I'm going to go to my calculator. And if I do this on the calculator, I get 29. So x equals 29 pounds of coffee. So that's the answer on this one, 29. All right, folks, hope this is helpful as you're working in Module